This video will cover the third page of notes on the topic of inverse functions. We have discussed how to find the inverse of points, an inverse of an equation, and now we're trying to find the inverse of a graph. So let's say, for example, we are given the graph of f of x, where f of x is equal to the square root of x plus 5. Because the 5 is on the inside, we know it's going to move it 5 units to the left. So we can see the graph right here in pencil mark. That's our f of x. And then what we did know is we found out that if you are 1 to 1, then we can switch the x's and the y's. So in the marker, you'll see that I have the line y is equal to x. And then the last thing that I have on here is going to be a colored pencil, and I think I have it in blue, for the inverse of f of x. So remember, we found out that if we had a point over here, so I'm going to go back to graphing my f of x, we had that in pencil mark. We would start here at 5 units to the left, then we would go over 1, up 1. Then we don't have a multiplier, that's the reason why it was only 1. I'm going to go 1, 2, 3, 4, and up 2. The next one would be 9, because the square root of 9 is 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3. So you see where I'm finding these points. And then in particular, let's write them down. So we wrote down one of them already as negative 5, 0. Another one is negative 4, 1. That's this one right here. And then we also found this one, which was negative 1, 2. And then we found this last one over here, which was 4, 3. So what we did when we had points is that we just switched them around. So the negative 5, 0 became 0, negative 5. That's this point down here. And then if we change this point, negative 4, 1, that becomes 1, negative 4. So that's 1, and here's that point. This one was negative 1, 2. It'll become 2, negative 1. This one was 4, 3, becomes 3, 4. And we'll see that it looks like this in blue. In fact, if we had this piece of paper and we folded it along the y is equal to x axis, this pencil graph would be right on top of this blue graph. So that's another relationship that graphs have that are inverses of each other. So again, we can practice finding the inverse equation of this. Notice that we had our f of x was y is equal to the square root of x plus 5. We know the domain is from negative 5 to infinity. We're going to switch the x's and y's because this is a one-to-one function and we're finding the inverse. And then we have to solve for y. So we squared both sides. That's how we get y plus 5 is equal to x squared. And then we're subtracting 5. So this is our equation. And in fact, the blue one for our inverse is y is equal to x squared minus 5. But remember, we only want this side of it. So in this case, we would want to make sure that our domain is going from 0 to infinity. But check this out. The range of my inverse function, notice the y values are going from negative 5 to infinity. That is where those two changes happen when we switch the x's and y's. The x's are for the domain, became the y's for the inverse function of it. So let's try one more. For example number 4, let's say we have an exponential function. An exponential function is the one where we have a base and our exponent is what has the x value in there. So our f of x is equal to 2 to the x power. And if we go back to our parent functions, we would actually find this graph looking like this. That would be what I would call my ballet move. So that would be our parent function. We can see that it is one-to-one, so that's a yes. So then the next step we would have to do is to switch our x and y. So we would switch them, and that's what we have here. Then our next step is to solve for y. But we don't know how to do that yet. That's what we're going to talk about in the upcoming lectures. The last thing I want to mention is the important facts about inverses. We know that if we have a function that is one-to-one, then the inverse function exists. If the domain of f is equal to the range of its inverse, in other words, we just figured that out, that the domain of one is going to be the range of the other. Likewise, the range of this one will be the domain of the other. So we did talk about that. And then the last one is that if you have a point and it lies on f, then when we switch the x and y's, the point BA lies on the graph of the inverse. And we talked about that and how they are reflections of each other across the line y is equal to x. And that concludes this video.